Good morning, hello, and good afternoon, everyone. My name is Yuichi Mori, working at the University of Oslo and Showa University in Norway and Japan, respectively. Thank you very much for your invitation, Philip. It is my greatest pleasure to present this exciting topic, namely making a change in clinical colonoscopy with AI technology. First of all, I'd like to disclose the conflicts of my interest here. And then I'd like to skip to the role of the AI in colonoscopy. As you can see, there are roughly three roles in the field of AI in colonoscopy, starting with the computer-aided detection, followed by the computer-aided diagnosis, and the computer-aided quality assurance. I'd like to start with the computer-aided detection. But before doing that, I'd like to introduce the current status in the market. As you can see, in the CADE field, there are roughly 9 AI devices on the market already, especially in Europe, United States, Japan, and some Asian countries, including Hong Kong. And also, when it comes to the CADX, there are roughly 5 devices on the market. So we have a chance to use that right now. Let's look at the Olympus Corporation, which is a kind of king in this field. They are providing two kinds of lineups. One is EndBrain, the other is EndoEdo in colonoscopy field. And when it comes to the EndBrain, there are 4 software. One is for CADE, which is called EndBrain I. The other 3 include the EndBrain, EndBrain Plus, EndBrain UC, all of which are CADX for colonoscopy. And we have EndoEdo, which is a genuine product provided by Olympus Corporation. And this product was designed to fit in X1 processors. So if you have this latest model of the processors in your unit, it's time to go for EndoEdo. It is basically for polyp detection. And when it comes to the clinical evidence, apparently use of AI contributes to the increment of ADR. This is really big gain in terms of clinical benefits because increase of the ADR can contribute to the reduction of colorectal cancer in the long run or reduction of interval cancer. This is a really important gain from my perspective. And these benefits may be included in the detection of large-scale polyps, such as polyps larger than 10 mm or adenomas larger than 10 mm. Let me pick up some examples. This is the latest clinical trial published by a Japanese group. This is a tandem randomized controlled trial comparing between the use of AI and standard colonoscopy. And as you can see on the left, there are roughly 2 advanced adenomas which were missed during the standard colonoscopy but were eventually found with the aid of AI. So these kind of polyps or adenomas larger than 10 mm can be the nice targets of using AI during colonoscopy. And this is another interesting example. Actually, this AI found the presence of the depressed colorectal cancer during colonoscopy. It embedded into the submucosal layer. So from my perspective, AI is not beneficial only for colonoscopic polyps, but also the invasive cancer recognition. In line with the development of the AI technology and the establishment of the clinical evidence, a guideline is also published by European Society of GI Endoscopy. According to this publication, use of AI during colonoscopy is weekly recommended based on the expert opinion. So how to maximize the benefits of using AI in actual clinical practice? I have an interesting idea to maximize the benefits. So just before explaining the benefits, I'd like to focus on the reasons why adenomas are overlooked by human eyes. Actually, there are roughly 2 reasons. One is the exposure error, the other one is a recognition error. Apparently, we cannot find anything unless we visualize the submucosal surface or mucosal surface in a real-time fashion. Now, this is called the exposure error. And also, we may overlook polyp when it comes to the very tiny, subtle appearance. So these kind of two errors may play a really important role in overlooking the polyps. Why don't we use the two devices to cover these two drawbacks at the same time? For example, we have the endocuff provided by Olympus Corporation, which is used to expose the mucosal surface in a real-time fashion. And also we have the AI for polyp detection, such as the endo-ado or endo-brain eye. So combined use of these two devices may contribute to increased detection of adenomas. And this is an example video which illustrates how to visualize the polyp during the examination with use of the endocuff and endo-ado at the same time. Apparently, it is very beneficial to use two kinds of devices at the same time for polyp detection. But which one is more beneficial for polyp detection, AI or endocuff? This is a very important and interesting publication coming from the Italian research group. According to this network meta-analysis, contribution of AI to ADR is much higher than that of the endocuff or other mucosal exposure device. So if you have a chance to use either AI or mucosal exposure device, I would recommend you use AI in terms of the benefits of getting higher ADR. But of course, we have a lot of the knowledge gaps or drawbacks in the field of AI in colonoscopy. Let me pick up a couple of problems. First, we don't know the performance of AI in colorectal cancer screening program, which is very important measure to prevent the colorectal cancer in the long run. Apparently, there is no publication in the field of AI in screening colonoscopy, and also we don't have any data in terms of the benefits of using AI for follow-up colonoscopy after FIT positive testing. But apparently, there are several numbers of the ongoing trials to establish the value of AI in colorectal cancer screening. So let's wait for a couple of years to find the best solution to maximize the benefits of using AI in colorectal cancer screening programs. And also, we don't know how increased ADR contribute to the cancer reduction in the field of AI in colonoscopy. To overcome this drawback, we conducted the microsimulation modeling under the following assumption. We assume that every 10-year screen colonoscopy is done with 60% compliance between 50 and 80 years old population in the United States. And according to this microsimulation, we can gain roughly 5% reduction in terms of colorectal cancer incidence compared with a standard colonoscopy screening. I guess 5% reduction is huge given the prevalence of colorectal cancer in the world. And also, we don't know how cost-effective it is to use AI in colorectal cancer screening. It is very important to understand the cost effectiveness if we look at the implementation of AI in clinical practice. And also, it's a little bit tricky to understand how it works in terms of cost effectiveness because CADE may contribute to cost increment because it can increase the detection of polyps, detection of the adenomas, which means the increased number of polypectomies will be expected. But this kind of cost increment can be mitigated with use of the benefits of having colorectal cancer prevention induced by the use of AI. According to our microsimulation, surprisingly, we can expect a cost reduction of using AI eventually. This is because we can get a lot of benefits coming from the reduction of colorectal cancer in the long run. This is a really big news to me because we predicted that, or we suspected that the use of AI may contribute to the increment of the cost. But anyway, we can proceed to the next topic, namely computer-aided diagnosis. Actually, the main role of the use of AI for polyp characterization is the reduction of the cost for polypectomy. We can reduce the cost of polypectomy by identifying the hyperplastic polyp in a better way than using our own eyes. For example, this is the publication by Canadian research team. AI correctly identified a neoplastic pattern of the polyp in a real-time fashion. But unfortunately, this device is not on the market. However, we have the Fuji device, and also we have EndBrain provided by Olympus Corporation. But when it comes to the clinical evidence, there have been only 6 prospective studies published in the field. And further, unfortunately, the quality of the study is not so high as that for the computer-aided detection. For example, there is no multi-center study, there is no randomized controlled trial, and most of the studies included less than 100 patients. So the quality of the study, as well as the statistical power of the study, is much less than that for the polyp detection. But let me show one example, which is the largest scale study in the field. This is our attempt published in 2018. We have included roughly 800 patients in this study in a prospective fashion. All the participants underwent the AI-assisted colonoscopy in a real-time fashion. As you can see in the video, we use the EndBrain, which is designed to interpret the image obtained from the use of endocytoscope. As you can see, AI can predict the histopathology in a real-time fashion in a really accurate way. But how about the additional gain of using AI or computer-aided diagnosis when compared to the standard colonoscopy measure? And this is a very interesting study published by Korean research team. And surprisingly, this study showed that there was no gain in terms of sensitivity when we have a chance to use AI for polyp characterization. So this is a really big surprise to me because we suspected that the use of CDX may increase the sensitivity for adenomatous recognition. But the answer is no, according to this retrospective study. We'll see by using the prospective data. This is the latest publication, not a publication, but the latest trial, which has just finished this spring. And this prospective comparative international multi-center study will give us an answer whether AI can contribute to the sensitivity increment or specificity increment in terms of the adenomatous histopathological recognition. So, ladies and gentlemen, I'd like to summarize my talk very briefly. First of all, in terms of the computer-aided detection for polyp, I have a really strong expectation on its benefits, including its role in colorectal cancer screening programs. But when it comes to the CDX, I'm a little bit skeptical because of the lack of the evidence. Let's see. Maybe we should wait a couple of years to identify the real benefits of using CDX in clinical practice. Thank you very much for your kind attention.